Hey guys, welcome back to new video, and in this video we're gonna build a dictionary app. And this dictionary app we're gonna build with the help of MVVM architecture. So during this video we will learn about MVVM architecture, how we can use MVVM architecture in real world projects. So without wasting any time, let's get started with our project. In MVVM we are having three things: model, view model. Responsibility of model is to fetch information either from remote or local data source. Responsibility of view model is to provide business logic on this data that we are receiving from model. Lastly, we are having view. Responsibility of view is to show the information to our user. So this is MVVM architecture. Now let's begin with our project and see how we can use MVVM architecture in our project. So first thing first, open up your Lisp version toml file, and in this I have already added all the dependencies that I'm gonna use for this project. So these are dependencies for Dagger Hilt, then we are having a Retrofit dependency, and lastly the plugin Compose compiler and Dagger. On the top, corresponding to that, we are having versions. In your module app level Gradle file, we are having few plugins for Dagger, Compose compiler and Kotlin annotation processor. On the bottom, this is our dependency for Retrofit, Dagger Hilt. This is used to initialize our view model in composable screen that we will see in this video. And lastly, the lifecycle dependency. Root level Gradle file contains two plugins for Dagger and Compose compiler respectively. Alright, so now it's a very good time to begin with our project. So in MVVM architecture, we are having three things: model, view model. So view is already over here. It's time to create two different things. First for our model, and I'm gonna call this model as data. Next, view model. Okay, so now we are having two different package: model, view model. Because in this video I'm gonna fetch information from the REST API, that's why we require an API endpoint. So this is our API endpoint. So I want to search information for hello world, and this is our response. So I'm gonna simply copy this response, come back to our project, and in our data, or you can say model package, create one more package in it and call this remote model. In this remote model, I'm gonna create model classes or Kotlin model classes corresponding to our JSON. So for that, we are having a plugin Kotlin data class file from JSON. So simply use it, paste your response and give the name. So I'm gonna call this dictionary response. Simply click on this generate. So it will generate data classes for you. This is our dictionary response that contain array list of dictionary response item. In this item, we're receiving license, meanings, phonetics, source URL and word. And corresponding to that, we have few different data classes. Like for meaning, we are having antonyms, definitions, part of speech, synonyms, etc. Okay, so by using this, you can create model classes corresponding to your JSON response. And one more thing, our API will give an error message once you try to find some gibberish word information. So this is our error object. So I'm gonna simply copy this, come back to our project. For this, let's create a different package, and package name is error. In this error, we're gonna generate data class and call this error message. Alright, so this is our model classes, or you can say data transfer object, because this data is used to transfer our information, and that's why we will call this type of objects as data transfer objects. Alright, so now it's time to create an API service. So API service is a place that eventually use to fetch the information from remote data source. For that, we're gonna use a retrofit. So in this data, I'm gonna create a package naming remote, and in this remote, I'm going to generate an interface name is API service. In this API service, first we require the endpoint. So go back to your endpoint, simply copy this thing up, come back to our project, and on the top I'm going to simply paste it. So first we are having get. So this is a get HTTP request, and in this we have to mention our endpoint. So this is our base URL and rest of things are endpoint. So simply copy this stuff. This is our endpoint. Paste it over here. Suspend function get meaning. And in this we have to pass our word. This is our word in the URL. So for that, I'm gonna use here pair of parentheses and call this word. Now in order to pass the word, we will use path. Make sure to spell the exact same word that you have spelled in your endpoint. simply call this word, type is string, and this will return us a response. Make sure this response is coming from your Retrofit library, and in this we are receiving dictionary response. So by using this, we actually fetch the information from a remote data source. Now it's time to begin with our dependency injection. So in our data, I'm going to create one more package for dependency injection, and in this dependency injection we are having an object, and the object name is data module. I want to install this thing in singleton component. This is a module, so use here module annotation. First I'm gonna provide my retrofit. Return type is retrofit. Return retrofit builder. We have to use base URL, so in place of base URL, go back to your API service interface. This is our base URL, so simply copy this thing, come back to data module and paste our base URL. Next we have to use add converter factory. So in this converter factory we have to pass converter factory that actually convert your JSON response into Kotlin model classes. So for that we will use JSON converter factory dot create, and lastly I'm gonna build it. So this will give me retrofit. Now by using this retrofit object, I'm gonna write the implementation of our API service. Again, provide function. This will provide me API service. We have to pass our retrofit in it. Return type is API service implementation. Return retrofit. This retrofit create a function naming create. In this we have to mention our API service class type. So API service class dot java. This will give me an implementation of our API service interface. Okay, so I want this object to be singleton. So for that you can use singleton annotation. Now it's time to create a repository. So for that we are having a package, and the package name is a repository. In this we have a class, and the class name is dictionary repository. In this class we have to pass our API service, because API service is used to fetch the information. We are having one function get meaning in it. Simply pass your word that you want information about. This will return you result. So this result is coming from Kotlin. In the result we are receiving dictionary response. So first I'm going to create a variable naming response. Using our API service, fetch the information from the backend. If our response is successful, on that case I'm going to return result.success, and in this success I'm going to pass my body. So response body, and I'm sure this is never be null. Else if it is not the case, on that case we are receiving some error message. So what we are going to do, we're going to simply take the error message, which is coming in the form of response error body use string. So this will give you a JSON string. Now it's time to convert that JSON string into our error message. So for that we're gonna use JSON. Import this JSON. In this JSON we are having one function from JSON, and in this we have to pass our string. Next the type. So type is error message class.java, and this will give me my object. Now I'm gonna return my result failure, and in this failure we have to pass the exception. So simply use exception object. In this you can pass the message. So object dot message. That's it for the repository. This repository contain a single function get meaning, and with the help of this meaning we get the information about my word. Let's begin with our view model. So in the view model I'm gonna create a class, and the class name is dictionary view model. This class will extend view model to inherit all the properties of our view model. On the top use hilt view model annotation, because we want hilt to initialize this view model. And I want to perform constructor injection. Import this inject. In this I'm gonna pass my repository. In this view model I'm gonna create a function, and the function name is get meaning. Pass your word. Type would be string. We will use a view model scope, launch a new coroutine. use our repository get meaning, pass the word, and this will give me my response. So if our response is success, on that case I'm gonna update my UI state that we haven't created yet. Else I'm gonna again update my UI state. So let's create UI state. So for that we are having a data class, and the data class name is UI state. In this we are having three different things. Is loading boolean, next the error. So error is nothing but a type of string. Initialize this thing with empty string. Lastly the actual data, and the data representing dictionary response. Initialize this thing with null. On the top I'm having private val UI state naming a mutable state flow. Initialize this thing with UI state. Just below to it I'm having a exposable UI state, that is initialized with the help of UI state as state flow. And one more thing, we are requiring here a query mutable state flow. So this query will be updated when user try to find some new words, or you can say it will represent the query that user want to search from our API. So for that, private val query, this is nothing but a mutable state flow, and initialize this thing with empty string. In our init block I'm using ViewModel scope, launch a new coroutine, query debounce. So debounce will use to provide throttle. So after 1 second, if user doesn't type anything, on that case I'm gonna check whether our query is empty or not. So if it is not empty, on that case I'm gonna collect the changes, and these changes will be updated our query mutable state flow. Just below to it I'm getting one more function, update query naming. In this query we are receiving word, and this is used to update our query. So in collect latest, instead of updating our query, I'm gonna hit my API get meaning and simply pass my word. So if our response is successful, I'm gonna update my UI state with the response body. So UI state contain data, and this data is coming from a response dot get or throw. In our else case, UI state update UI state update our error parameter in it, response dot exception or null. This will contain a message, so simply pass that message in it. So in get meaning function on the top, just update our UI state is loading true, so that we are able to show our user a circular progress indicator. So that's it for our dictionary view model. Now it's time to begin with our composable. So for that, open up the view, and in this view I'm going to create a file, and the file name is dictionary screen. In this we are having a composable, and the composable name is dictionary screen. Requirement of this dictionary screen is our view model, so simply pass our view model. We are having a variable, and the variable name is a UI state, which is initialized. View model UI state collects as state with lifecycle. So what it will do, it will simply collect our mutable state flow in the form of state, so that if anything got changed in our mutable state flow, that change will be reflected in our composable. And next we want to begin with our scaffold. So in this scaffold we are having top bar that contain text field. So in order to hold this state, we are having a state naming query, which is initialized with the help of remember savable mutable state of empty string. Import this thing up, used your query value over here, and if anything got updated, simply update your query value. In this text field we are having colors parameter, and this color is, and you can change this color with the help of text field default dot colors. So we are having a lot of parameters in it, but I'm gonna use here unfocused indicator color, which is transparent, and next focused indicator color, which is also transparent. So we are pretty much done with our text field. One more thing, make sure to use here a modifier fill max width. Now it's time to begin with our content that present in our scaffold. So first I'm going to check my UI state is loading parameter. If it is true, I'm going to create a box having modifier fill max size. But before this fill max size, let's add padding that we are receiving from the scaffold. and its content alignment will be on the center that contain a circular progress indicator. So this is the case of loading. If our UI state error is blank, not blank, that means we are receiving some error, and on that case I'm gonna create a box, fill max size, content alignment is on the center that contain text in it, and this text is used to show us the error. Lastly, the success state. So UI state data let, and we are receiving response, the dictionary response. This will contain a lazy column. Lazy column having a modifier, padding it, fill max size. In this lazy column, we have a function naming items, and this item is used to render our list one by one. So I'm gonna pick items that has list of type T in its parameter. Use our response, convert this thing in a form of list. We are receiving item one by one in our items trailing lambda. So now it's time to create our list item. So for that I'm going to create a different composable, and the composable name is list item. In this we will have to pass dictionary response item. So for that we are having dictionary response item as a parameter, and also I want to see its preview. So preview show background is true. So in order to see the preview we have to pass our dictionary response item. So for that I'm having a fake dictionary item over here. So make sure to import everything. Alright, so now go to this definition and change the type from any to string. Similarly for the synonyms, any to string, and make sure this example sometimes come nullable from the backend. So make sure to use question mark operator. Come back to our dictionary screen and begin with our list item. Use our dictionary item here. Now we are having a column, and this column have a modifier, fill max width. Just before this fill max width I'm gonna add padding. Horizontally 16 dp, import this dp, vertically 8 dp. Just open up the preview, refresh the build. Okay, so now here we are having our preview. So yeah, this is our column, and in this column I want border. Width is 1 dp, color is black, and its shape is a rounded corner shape of 12 dp. In this column first I'm going to create a text, and this text is used to show us the word that we were searching for. Dictionary response item word. In place of style I'm using material theme dot typography display medium. Change its color from black to red, and also its font weight would be bold. So this hello is stick to the left side of our column. So I want some padding. So padding, let's say 12 dp. Now it looks fine. So this is our word. Just below to it I'm gonna add one more text, and that text is nothing but the meaning of this word. So for that I'm gonna use dictionary response item meaning, iterate it, that will give me meaning. First I'm gonna add text, and this text is used to show us the part of speech that is coming from our meaning dot part of speech. Next we are having a modifier fill max width, and its background color is green. So color green. I want to give some padding in it, so in order to give padding, next I want padding of 8 dp, and also I want the shape of this color is a rounded corner shape. So for that pass a rounded corner shape 12 dp. Alright, and also need some space. Modifier height would be 12 dp. Now it looks fine. Now in place of style I'm gonna use material theme typography headline medium. That's it. Now just below to it I'm having a spacer of height again 12 dp. Now in our meaning we are having definition. So in our definition I'm gonna perform iteration. Make sure to give the name definition. I'm gonna create a card, and this card having modifier fill max width. In this card I'm having a column. This column contain a modifier fill max width, but before this I want a little padding across our column, so padding would be 8 dp. Now this column contain a text, and this text is used to show us the definition, having a style of material, theme, typography, body, medium. So this is our definition. Next we are having synonyms and antonyms. So for that, first I will check if my definition dot synonym, if it is not empty, on that case I'm gonna create a text, and this text says to us synonyms. Use my definition synonyms and join this thing to string, and my separator is comma. In place of style I'm gonna use material, theme, typography, again this time body, medium. So this is our synonyms. Similarly for the antonyms, I'm gonna copy this stuff, paste it over here, change this thing from synonyms to antonyms. So this is our antonyms. Next we are having examples. If our definition dot example is null or blank, if it is not the case, on that case I'm gonna show you the example. So text definition dot example, but before this I want to add example so that it is very clear that this is our example. In place of style I'm gonna use material, theme, typography, again body, medium. So yeah, this is our list item. Now it's time to use this list item in our lazy column items function. So over here, list item, pass your item in it, and this item is nothing but our dictionary response item. And yeah, we are pretty much done with this list item. Now it's time to use this dictionary screen in my main activity. So go to your main activity, and in this main activity remove this greeting with dictionary screen, pass your view model. So view model is initialized with the help of hilt view model. Hilt view model, mention the type, so type is a dictionary view model, pass your view model here. And one more thing, we have to set up our dagger hilt dependency injection framework. So first make sure to annotate this thing with Android entry point, and next we have to create our base application class. So in our dictionary app I'm gonna create a class, and the class name is base application. This base application extend application, annotate this thing with hilt Android app. Now go back to your manifest. On the top, first thing first, add permission for the internet. Next mention the application name, which is base application. And now we are pretty much done. It's time to execute our application. Alright, so we are having a problem, and the problem is I haven't provided this dictionary repository through my dagger hilt dependency injection framework. So let's do that. Go to the data module, and in this data module write a provide function which will provide us the repository. And the requirement of repository is our API service. This will give me my dictionary repository. Dictionary repository, pass your API service. Now re-execute this application. Alright, so our app is executing. Now when I type hello, nothing happens because in our screen, dictionary screen, we haven't hit our view model update query function. So let's do that. In our text field, on value change, we will use a view model and update our query with our query that user types in our text field. And one more thing, go to our main activity, wrap this dictionary screen with a surface, and this surface having modifier padding of inner padding. Cut this screen from here and paste in surface. Now re-execute our application. So our app is executing, but we are not receiving any meaning for this word. This is because in our text field we haven't called a view model update query and pass our query that user types. One more thing, in our update query make sure to use this word instead of it. Now re-execute our application. Alright, so I'm gonna type here hello, and here you can see this time we are having the meaning of this word, but our card got stuck across one another. So let's fix this. Go to our dictionary screen. On the bottom we are having a list item. This list item contain card, and I'm gonna add padding, and this padding is vertically 4 dp. Now on the top in our text field, I'm gonna add placeholders so that it is very easy to see that we are having a search box and user can type the word that he want to search. So placeholder is nothing but a simple text which says search. Now re-execute our application. Okay, so I'm gonna type here hello. Now it looks way better than before. Alright, so that's it for this video. I hope you like this video. It's a very simple video. In this video we saw how to use MVVM architecture in real world projects. So we will meet in our next video where we will discuss something new about Android. Till that, goodbye.